Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Badrul Munir bin Muhammad ZABIDI. So right now, I would like to present about the project background of case study 1. So first, the project overview. So the name of the project is Cadangan Membina Dewan Serbaguna di RRM Tanah Putih Baru Majlis Pembandaran Kuantan. So the client for this project is Majlis Pembandaran Kuantan MPK. So the location of this project is located at Taman Tanah Putih Housing Estate, approximately 2 kilometers from Kuantan's main area. So the timeline for this project is start date from April 25, 2016, and the completion date is from April 15, 2017. For the financial overview, the total contract price is RM 880K, including GST of RM 46K. So the key stakeholders for this project is Ministry of Housing and Local Government KPKT, Kuantan City Council MPK, and Max P Enterprise, which are the contractor. So the project objective is to provide a versatile space for community events, athletics, culture, and public gatherings. And then the objective also to support local development and enhance public facilities. So the need for the project is existing hall facilities were insufficient due to rapid local development, and the new hall replaced the demolished existing structure to meet community needs. The community's infrastructure importance to enhance social interaction and living standard. It also provides flexible spaces for activities that spur community development. So next, I would like to present about the soil types and properties that case study 1 use. So the soil types that case study 1 use is first, lateric soil. The characteristic of the lateric soil is contains iron and aluminum oxides, red to brown in color, strong and stable in dry condition. So the construction implication of lateric soil is high bearing capacity but low permeability can lead to runoff and erosion. It also requires adequate drainage and waterproofing to prevent water accumulation. Next is sandy soil. So the characteristic of the sandy soil is fine texture, highly permeable, and drains well. So it also non-cohesive nature make it susceptible to erosion. The construction implication of sandy soil is it needs to stabilization with retaining walls or geotextiles. Compaction is essential to reduce settlement and increase strength. And last but not least, the soil type is alluvial soil. The characteristic of this type is mixture of clay, slate, and sand found along river valleys. Well-drained and fertile but variable in composition. So the construction implication of this alluvial soil is it requires stabilization and compaction for uniform density, and it also good compaction increases load-bearing capacity for foundations. The key consideration of soil types and properties for this case study is the bearing capacity of each soil type directly affects the stability of building foundations. The proper drainage system are essentials, particularly for lateric and alluvial soil, to manage water flow and prevent erosion. The third content of the case study 1 is the scope and magnitude of the earthwork operation. So first, we will overview of earthwork activities. Earthwork for the multipurpose hall project is divided into two main phases, which are preliminary work and work below the lowest floor finish, which are WBLFF. So first, preliminary work. For the site preparation, we're clearing and grubbing to remove vegetation, trees, and stump. Second, we demolish of existing structure if necessary. And last, removal of debris and rubbish from the site. So second is WBLFF. For WBLFF, we excavate activities. We have the excavate activities. First is oversight removal. For the depth is 300 millimeter from the formation level, and the area is 980 square meters. It requires extensive excavation and accurate grading. Next, we want to do the pad footing excavation. For the depth up to 1.5 meter from the formation level, the volume is 20 cubic meter, and it needs to be a careful management needed for stability and measurement accuracy. And last is trench excavation for ground beams. The depth is not deeper than 1.5 meter from the formation level, and the total volume to be excavated as per design specification. So the key consideration in the scope and magnitude of the earthwork operation is all earthwork operation must adhere to standard requirements for safety and quality. The proper Danish solution are essential to manage water flow during and after excavation. So the next content that we will look in this case study is the tools and equipments for excavation operation. So for this case study, we use excavator, compactor, and dump truck. So for excavator, we know that the primary functions is to digging, moving, and transporting materials. The component of excavator is boom, dipper, bucket, to control by hydraulic system for precision. So the key benefit of excavator, it is strength, efficiency, and adaptability that make it irreplaceable in construction. For compactor, we know that the primary function is to compress a material to improve stability or reduce volume. The size range of compactor is small, handheld to large ride-on models, and the application is to construction, landscaping, and waste management. For the key benefit of compactor is to ensure stable and durable surface of foundation. And last but not least, the dump truck. The primary function of dump truck in this case study is to transport and unload loose material like soil, sand, or debris. For the component, the dump truck use cab, chassis, hydraulic system, dump bed, and wheels. And the key benefit of dump truck in this case study to speed up material transport and unloading for greater efficiency. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shabil. So I will continue to discuss about the excavation, grading, backfilling, and compaction technique used. Used in the cadangan membina Dewan Sebelum Projek. For excavation, both manual and mechanical methods are used, ensuring accurate and efficient site preparation. Grading includes rough and fine grading utilizing heavy machinery like bulldozers for precise leveling. For backfilling technique, stabilize foundation with layers of materials like sand and gravels, and compaction ensures stability by using vibratory and static methods to achieve proper density. These techniques are essential for creating strong, stable and foundation for a construction of the multi-purpose hall. Continue for the safety procedure and environmental regulation. For the construction of uh, multi-purpose hall, safety is a top priority, with strict adherence to OSHA and IOSH NIOSH ataupun DOSH DOSH Malaysia regulation. These include personal protective equipment, safety training, regular inspection, and emergency response planning. Environmentally, the project follow waste management practice, pollution control, and conservation efforts. This includes recycling materials, controlling dust and noise, and conducting environmental impact assessment to protect ecosystem. Additionally, green building standards ensure energy efficiency and sustainability. This ensure this measure ensures the project success with minimal harm to workers and the environment. So for this slide, the problem involves solution and recommendation for the Tanah Puteh multipurpose hall project. Key issues include construction site safety, environmental protection, delay, cost overruns, and community disruption. Safety measures such as training, PPE, and regular inspections are crucial. Environmental sustainability is addressed through waste management and green building practice. To minimize delay and cost, proactive risk assessment and stakeholder engagement are essential. Community disruption can be minimized with effective traffic management, pollution control, and open communication. By addressing these challenges comprehensively, we ensure a successful project for both community and environment.
So my name is Ahmad NASRON, and next slide is case study number 2, which is cadangan membina Dewan Paya Besar dan kerja-kerja berkaitan di Kuantan. So for project overview, the name of the project is what I say just now, which is cadangan membina Dewan Paya Besar dan kerja-kerja berkaitan di Kuantan, and the client for this project is Kementerian Perumahan dan Kerajaan Tempatan. For the location for this project is the eastern part of Kuantan at Lorong Pandan Damai 1/36 Kuantan, Pahang. Next, for the project objective, this project is to provide upgrade facilities and service for residents with designated area for the different users, and also the uses for the neighborhood event, educational program, and community gathering or meeting. For the timeline for this project is that the project is January 21 2019, and the duration for the construction for this project is which is 78 weeks. For the next point, which is the what who cooperate with the client to construct the project, which is Kuantan City Council, which is Majlis Pemadaran Kuantan. Then the other team member involved, which is Jurukubahan Pendeta Sdn Bhd, SZY Consultant Sdn Bhd, and architect from Lembaga Arkitek Malaysia. Next is financial view. So the total contract price for this project is 68,013,582. For the building infrastructure, they have hall area, surau male and female, utility room 1 and 2, and the others. Next, for the key stakeholder, which is Ministry of Housing and Local Government KPKT, Kuantan City Council MPK, and Mac Enterprise Contractor. So for the next slide, which is soil types and properties for this project. So first one is sandy soil, and the characteristic of the sandy soil, which is have a superior drainage qualities. Sandy soil are prone to erosion and instability due to the cohesion. So the construction implication for this project are to sandy soil, which is procedure for stabilization such as geotextile application and creation of compacted layers. Next, it is to improve the stability by preventing soil shifting or setting. Next soils, which is alluvial soil, and the characteristic of alluvial soils, which is general found in river, valley, and coastal plain, is soil are often these soil are often a mixture of different proportion of clay, silt, and sand. So the implication for the soil in the construction, which is a high degree of compaction, is necessary to enhance the load bearing capacity of the soil and achieve a consistent density. For the third soil, which is lateritic soils, so the characteristic which is lateritic soil are extremely hard when dry with high iron and aluminite oxide content. So the implication for this project for this soil is the engineering team install advanced drainage system in order to reduce the risk of soil saturation, erosion, and shifting foundation. So next slide is the scope of work for this project. First stage is stage of earthwork, which is a preparation removal of trees, stump, plant, and obstacle. So the excavation, which trench for ground beam, is 1 until 2 meter deep, 185 cubic meter. So an excavation for pile top is 2 meter deep and 86 cubic meter. Grading, you use a rough grading, land leveling for construction, and fine grading, which is adjusting topography for stability of slab and foundation. For the backfilling, the compaction of excavated areas, including trenches for utilities, compact layer of concrete slab, which is 250 thick and 2,267 meter cube and meter square area. And lastly, 591 cubic meter of imported earth used for ground floor slab in backfilling. For the next stage, which is the next scope of work, is drainage. Drainage, it is to proper dredging for pipe to ensure effective surface water management, which is carefully referring to maintain water flow continuity. Next, the equipment used for this scope of work is this project, which is a grader, compactor, backhoe, bulldozer, excavator, and dump truck. For the environmental consideration, which is erosion control, we use silt barrier, erosion control blanket, and for dust suppression, we use water truck to minimize airborne particle. For the noise and vibration control, is to meet a community standard. For the key, the objective of this project of this cover is efficient and environmentally responsible work to support the whole foundation and infrastructure.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Muhammad Umar Mustafa bin Muslim Al-Sani. So we go through to the tools and equipment for excavation operation in this project. So we go to the first one, which is the excavator. The primary use for excavating, moving, and transporting materials like soil, gravel, and sand. And the key components of the excavator is boom, dipper, and bucket. And the function of the excavator is to make a trench and digging the soil and excavate the foundation and for site preparation. And what the benefit of excavator? It have a high accuracy and versatility, fast and efficient for heavy tasks like excavation and metal lifting, and it's easy to adapt for various project size and condition, and it have a 360-degree rotating cab for easy access to tight space. And the importance of excavator is for earth moving task and to help the construction project to stay on the schedule. So next we have the bulldozer, which is the primary use for leveling the soil, remove the debris, and to prepare the construction sites. And the key components of the bulldozer, because it has a large size, heavy blades for pushing dirt, rock, and soil, and the tracks of the bulldozer has the stability and traction on soft or uneven ground. So, what the function of bulldozer? The first is to clearing the obstacle like plants, rocks, and all buildings, and to move the large quantities of earth and materials, to compact and big filling for ground stability, and shaping the landscape, which is like cutting through hills and filling low area. So what the importance of the bulldozer, which is it's vital for the site preparation and ensuring safe and efficient for the construction. And then lastly, we have compactor, which is the primary use is to compact and compress soil to increase load bearing capacity and to reduce air pockets in soil and strengthening it for building support. And the importance of the compactor is to ensure the stable foundation by preventing soil settlement or shifting, and it is for the safety and longevity of the structure. So the benefit of compactor is it can increase the soil stability, and it can enhance the load bearing capacity, and to provide a stable foundation for the construction project, and it can improve the efficiency and safety during the construction. And for the selection is the type of compactor depends on the project needs and type of soil and size the construction project. Okay, so next we go to the excavation, grading, backfilling, and compaction technique use. So to the first one, which is the technique for excavation. What is the importance of excavation? It is essential for foundation and structural framework, and it involves digging trenches for ground beams and pit for pile caps. The equipment, the common use in the excavation, which is the bulldozers, backhoes, and excavators for accurate and efficient excavation. And the focus area, which is to achieve accurate in the correct depth and dimension as per plan, to ensure the safety during excavation, and skilled operator monitor works and follow the safety regulation. And the environmental consideration, which is we use of silt management the use of silt management barriers to reduce environmental impact and erosion control to protect the site. And the objective of this technique is to ensure the underground stability for the whole construction and to meet environmental and project schedule. So as you can see the diagram, which is it's one of the technique of excavation, which is the cut and fill method. Okay, so next we go to the techniques for grading. So the method for techniques for grading, which is we go through to the first, we have the cut and fill, which is it can balance the on-site earthworks by removing excess materials and reusing it where elevation is needed. Next, we have modern technology, GPS and laser guided machines ensure accurate and efficient grading for plan, elevation, and slope. And the subgrade preparation is used of rollers and compactors to stabilize the subgrade for structural loads and proper drainage. And the environmental consideration for the erosion control, the silt barriers and erosion control blankets to prevent soil erosion, and the separation, which is the method to minimize airborne particles and protect community well-being. So what the outcomes of these techniques for grading, which is it can precise the site preparation, smooth the construction schedule, and enhance the environmental sustainability. And the commitment to delivering high quality infrastructure for the community. And as you can see, the diagram for the techniques for grading is one of the method that I mentioned before, which is the GPS and laser guided grading. Okay, so we continue from the last slide. So as you can see, we go through to the techniques of backfilling. So what the purpose of backfilling? So it's to provide stability and support for construction progress as planned. And the key techniques is compaction and layering, which is the backfill material is added in stages and compacted using plate compactors and vibrating rollers, and it to prevent structure layer from sinking over time and ensuring the stability and density. And the lean concrete is used in key areas to enhance durability and load carrying capacity. And the environmental consideration, which is the dust reduction to minimize airborne particles during construction, and the erosion control, which is the silt barriers and erosion blanket to reduce soil displacement. And what the outcome of this technique, which is to ensure the structure stability in construction efficiency and adherence to environmental standards for long-term success. So to the last one, which is the techniques for compaction. So the objective of technique for compaction is to ensure soil stabilization and a strong foundation for the multi-purpose hall as related to the case study. And the technique used, which is, as you can see, as it has a list of the technique used. For the first one, we have dynamic compaction, which is use vibratory rollers and impact compactors to rearrange soil particles, reduce void, and increase density. And the effective for cohesive and granular soils to prevent the settlement hazards. So the next technique, we have the grid roller compaction, which is employ steel drum rollers with a grid pattern for uniform compaction over large areas, and it enhance the load bearing capacity and reduce differential settling risk. And we have also the CDF, which is stand for controlled density field, which is the vibratory and pneumatic rollers achieve precise density in specific areas. And the environmental consideration, which is the dust separation method to minimize the airborne particles also, and erosion controls to reduce the environmental impacts. And the outcome of this technique, which is it can become the strong, stable foundation and adhering to engineering standards and the sustainable practice, ensuring quality construction and community satisfaction. So as you can see the diagram, this is the dynamic compaction, which is one of the technique used for the compaction. Okay, so the following slide, I will present about the safety procedure and environmental regulation. So we go through the safety procedure first. So for the safety procedure, we have a PPE, which is stand for personal protective equipment, which is include safety helmets, gloves, boots, high visibility clothing, and eye protection to reduce risk exposure. And for the safety training, the workers need to train on proper equipment use, hazard recognition, and emergency response, and the routine site inspection and audits to identify and address risk promptly. And next, emergency preparedness. For the emergency preparedness, they need to prepare the emergency action plan, which is to cover fires, accidents, injuries, and evacuation protocols, and the frequent drills, first aid training, and the communication workshop and readiness. And next, for the public and worker protection, it has a warning sign and fencing around the hazardous area, and make a regular maintenance to ensure safety measures effective remain effective. And the goal of the safety procedure is to maintain a safe and productive workplace while protecting workers and the public. So next we go through to the environmental regulation, which is it have a air, dust, and noise control, which is we use CDC to measure to minimize the pollution and improve condition for workers and nearby residents, and water and erosion management to implement system and to control the water flow and prevent soil erosion and to protect the local ecosystem. And next, environmental impact assessment to ensure natural habitats and wildfire and wildlife and preserve during the construction. And for the next point, waste management is it need to be efficient for waste reduction and recycling practices, and for proper disposal of hazardous materials in compliance with environmental regulation. So the sustainability goals for environmental regulation is to reduce the energy and water use and adapt eco-friendly practices and integrate green building standards. And it aims to meet international sustainability targets and lower the project's carbon footprint. So the outcome of this regulation is to minimize the environmental impact and enhance the resource of the efficiency. Okay, so in this slide, I will explain about the problem, involved, solution, and recommendation for this construction project. So we go through the first issue, which is the safety concern. The problem is the construction sites pose a hazard to the workers themselves due to changing site condition. And the solution is the project manager implement strict safety and health practices based on documentation And the recommendation for this issue is to provide the personal protective equipment for the workers, detailed safety training, frequent site inspection, and documented emergency for the response plan. And the next issue is impact on the environment, which is the problems. It involve dust, noise, and waste that have a negative impact on the environment. And the solution is we install the noise barriers, dust suppression system, and other materials. And the recommendation for this issue is green building practices such as the use of sustainable materials and energy efficient method. And the next issue is the project delays and cost overrun. So the problem is the project delays and cost overrun are other prevalent issues that put strain on resource and delay progress. And the solution is the communication with stakeholders, including community involvement, to increase the support and facilitate the procedure throughout the project life cycle. And the recommendation, which is we need to develop trust and confidence for a more seamless project to implementation the process. And then lastly, the disruption to the community. So the problem, the caused by things like noise pollution, traffic jams, and another pollution which can negatively impact to the local business and residents. So the solution is we need to put plans for the traffic management, noise barriers, and pollution prevention techniques. And the recommendation for this issue is to address the community problems well in advance by providing an ongoing flow on information.
Okay, the comparison between the case studies, the similarities and differences. First off, excavation. So the similarities for both A1 Tanah Putih and A1 Wawisa, they both have safety procedures that are given first priority in both projects to guard against harm to already existing structures, while environmental precautions include silt management and erosion control. The differences for the A1 Tanah Putih, it uses manual and mechanical methods with excavators, backhoes, and bulldozers. For the one besar uses modern techniques for precision digging, including GPS and laser-guided equipment. By using these modern techniques, they can achieve great precision in meeting the specification for depth in and dimension. Alright, next, grading. The similarities, they both use cut and fill procedures that are used to prepare the site for both projects. Then, they also use dust suppression and erosion control that have been implemented. And lastly, they both aim for accurate surface smoothing and leveling. The differences for the Tanah Putih uses on depends on traditional cut and fill methods with graders and bulldozers for basic grading. Meanwhile, for Dewan Paya Besar, uses modern GPS and laser-guided grading that are integrated with blended cut and fill to increase accuracy and the subgrade preparation. Right? For backfilling, the similarities, compaction techniques are used in both projects to provide stability and support while they are being built. Environmental issues are given top priority when it comes to erosion control. The differences for the Tanah Putih, it uses standard backfilling with vibratory rollers and plate compactors. For the Tanah Besar, it uses sophisticated compaction technology such dynamic and CDF preparation and specialist backfilling techniques like lean concrete to increase durability and density control. Lastly, compaction. The similarities, both projects employ a range of compaction tools to attain stability and consistent density. Then, the suppression and other environmental protection measures are put into place. Differences for the Tanah Putih, static rollers and runners are used to apply static compaction for smaller areas and laboratory compaction for larger areas. Then, for the Paya Besar, we employ a grid roller compaction control density field, which is CDF technique for particular zones, and dynamic compaction using vibratory rollers and impact compressors. To conclude this presentation, first of all, the importance of earthworks in construction. Earthworks are essential for the success of both project of Dewan Serbaguna Tanah Putih Baru and Dewan Paya Besar. It forms the foundation of all building activities from land preparation to soil protection. Next, cost-saving benefits. A cost saving can prevent expensive issues like foundation failure and drainage problem. Also, it can reduces the fuel and material waste, and by that it can lower the overall project cost. Then lastly, critical role of proper methods. And efficient methods and proper equipment ensure high quality outcomes, and it is vital to project success by creating a stable base for further construction. That's all.